In this video, we're going to practice factoring the expression by factoring out the greatest common factor. So let's take a look at this first example. Here, we have 2x squared plus 4x. So we want to know, what do both of these terms have in common? Meaning this term and this term. So which of those two terms, what do they have in common? So if we look, we see that their greatest common factor numerically is a 2, but yet they also both have an x that they're able to pull out. So we can factor out a 2x, which is going to leave us with, now this is kind of like division, so 2 goes into 2 one time, and if I have 2 x's here and can take one of them away, then I'll be left with 1x there, plus 4 divided by 2 is a 2, and x will cancel out the other x, leaving us with just a 2 there. And that is going to be our factored expression, and our greatest common factor was the 2x. Let's take a look at our next example. Here we have 16p minus 8. So this time only one of our terms has a variable. So we want to know what will go into 16p and 8. Well, we know that 2 will go into both of them, but 4 will also go into both of them. But is there a number that's bigger? And the answer is yes. 8 is the biggest number that will go into both. So I'm going to bring out my 8, and that's going to leave me with a 2p minus 1. Now let's say that I took my problem, 16p minus 8, and let's say that I only took out the 4, that I only thought about the 4 to come out. If that had happened, I would have been left with 4 times 4p minus 2, and I would have seen that here, those still had a number in common, which would tell me that I hadn't taken enough out. So I could either go back and restart the whole problem, or I could then decide that I also need to take a 2 out. And I would write 2 times the 4 that I had already taken out, and then finish it. Then I'd be left with a 2p minus 1. And then I'd finish by multiplying and get 8 times 2p minus 1 for my final answer. So you could do it that way as well. However, taking out the largest number to begin with definitely is less work. So here we have our factored expression. Let's look at our next example. Here we have 21c plus 15. What number will go into 21 and 15? Here we see that the largest number we can pull out is a 3. So we pull out our 3, and we'll see that we're left with a 7s plus 5. And that's going to be our factored expression. Let's take a look at number D, or letter D. Here we have 9b plus 24c. Well, we know that 9 won't go into both of them because 9 is not a factor of 24. However, 3 can go into 9, and 3 can also go into 24. Sadly, we can't take out one of the variables because it's a b and a c, and those are different variables, so we can't take one of those out as well. So having taken out the 3, that's going to leave us with a 3b plus 8. And that's going to be my factored expression. You can check to make sure that you've taken it out and that it's correct by simply distributing that 3 back in. Because when you distribute that, 3 times 3b would be a 9b, and 3 times a positive 8 would be a positive 24. And I can see that, wait a minute, that doesn't match. I'm supposed to have a C. So that tells me that I should have written a C right there. That way when I multiplied it, I could have had that C right there as well. But now that I know that I am simplified and that I have factored my expression fully. And so now we have our solution. Let's take a look at letter E. It's a little bit different. Here we have 1/2 times m plus 1/2. So if we look at our two terms, 1/2 m and 1/2, we want to know what they both have in common. And in this case, they both have a 1/2 in common. So we're going to take out a 1/2. So if I take out a 1/2, I'm going to be left with an m plus a 1. And that's going to be my fully factored expression. Let's take a look at letter F. Why don't you try letter F and see if you've got it right? Go ahead and push pause, and then when you're done, go ahead and unpause the video and see if you were right. So for letter F, we have 12xy plus 36xy. So we want to know, what do each of these terms have in common? So I know that a 2 will go into both of those. But I also know that a 6 will go into both of those. But I think also a 12 will go into both of those. As I'm looking, I can also see that they also have a variable in common. They each have an x. So I'm going to take out a 12x this time. And 12 divided by 12 is 1. And x divided by x is a 1. So I'm left with just a y in my first term, plus 36 divided by 12 is a 3. X divided by x will go away. I'm left with a z. And I now have my fully factored expression.